Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, dear students. Welcome back to this TV Learning Series program. As usual, I'm Teacher Patrick, and I'll be taking you through chemistry for Senior 5. You remember in the previous lesson, we're looking at the Unit 5, which is about the alcohols and ethers. We are still looking at the same, we are still on the same unit, and we'll also still continue with the chemical properties. There are some chemical properties that we looked at. I don't know whether you still remember those chemical properties. If you remember them, let me just also remind you about the chemical properties that we looked at. We looked at the reaction with alcohols, reaction with the sodium metal. And we said this reaction produces ethoxides, and the hydrogen gas is liberated. So the product, this produces the ethoxide, or sodium ethoxide in that case, and the hydrogen gas. You remember this reaction, I said it is very important because it can be used to distinguish or to test for the presence of alcohols in the laboratory because of the effervescence that we looked at. We looked at the combustion. Alcohols burn. So if you remember the combustion reaction, say they burn to produce heat, and therefore they can be used as fuel. That was the most important part of the reactions that we also looked at. Because they burn, then they can produce heat. And in that sense, they can be used as fuels for cooking, for producing any form of energy that is required. We also looked at the reaction with the phosphorus halides, and the sulfur dichloride oxide. Said the same reactions. We looked at the mechanisms for them, and said the same reactions can be used to test the presence of alcohols in the lab because they produce. For example, we said if this phosphorus halide react with alcohol, any form of alcohol, this is a nucleophilic substitution reaction. So this will produce the alcohol, the alkyl halide. So the OH of the alcohol will be substituted by the chlorine, and then this will produce the hydrogen chloride gas and this compound. So the hydrogen chloride gas will be produced in form of effervescence, and therefore that reaction also can be used to test for the presence of alcohols in the laboratory. The same reaction, if we said sulfur dichloride oxide reacting with the alcohol, because we looked at the same reaction with the alcohols, and we said this reaction, the same reaction, the chlorine here, if you remember the mechanism, I hope you still have where you wrote that mechanism so you can check and see that you'll find that the OH is substituted by one of the chlorine from this compound. And then this produces the hydrogen chloride gas and then produces the sulfur dioxide gas. What does this mean? Compared to these two reactions, I said both of them can be used to test for the presence. But sulfur dichloride oxide is a better reagent because it produces only gases and the product. So this one produces, this is also a liquid, this is also, there is a mixture of liquids. The alcohol, this alkyl halide will be mixed with this compound, and therefore you won't be able to separate which one is the alcohol. So that is those are the reactions that we looked at in the previous chemical reactions of the alcohol. So I said we are still continuing with the chemical reactions of the alcohols. So let us look at the reactions with the reaction of alcohols with carboxylic acids. Carboxylic acids. I mentioned a little bit about this reaction. If you remember, I said the product. Do you remember the product that I mentioned? Yes, I mentioned that the product is an ester, and esters are found in everyday life. You pass around in the compound, you feel a very nice scent around in the compound produced by the sunflowers. That is an ester. Some of the plants produce those esters. When you enter in the house and there are some yellow bananas, you immediately feel that in this house, there must be some yellow bananas, sweet-smelling compounds. Those are the esters found in those yellow bananas that are produced. In the pineapples, in the apples, you can easily feel the scent of certain compound of those. Those are the esters that are being produced, sweet-smelling compounds. So whether it is as a reaction, they are produced as a reaction between the alcohols and the carboxylic acids. So this is an example of the alcohol. This is a general equation. The alcohol with OH, it is reacting with a carboxylic acid. Any form of the carboxylic acid, we shall use a simple carboxylic acids, not long-chain carboxylic acids. So this is a carboxylic acid that is produced. The important information that this reaction takes place under certain conditions. And these conditions are in presence of concentrated sulfuric acid. This is a catalyst. It is used as a catalyst in this reaction. And there must be heat to around 100 degrees Celsius. That is some heat that is required. And then the ester is produced. This is the structure of the ester that is produced. With R and water is eliminated. So this reaction is referred to as esterification. Esterification reaction. Esterification reaction. So you can also call it condensation reaction because it produces the water. But mainly it is an esterification reaction because it produces the main organic product that we are looking at here is this ester. This is the general form of the ester. How does this reaction, esterification, take place? Let us look at the mechanism. Remember I said the mechanism is step-by-step events that occur at molecular level when a reactant is changing into the product. That is what we mean by the mechanism. And in most cases, we need mechanisms usually when we are writing, when we are forming these organic reactions. Let's proceed with the mechanism for this reaction. How does it proceed? So in the step number one, because I said it takes place in presence of concentrated sulfuric acid, so there is protonation. So the carboxylic acid is protonated by the acid, these hydrogen ions. Remember, the hydrogen ions are coming from the sulfuric acid plus hydrogen sulfate ions. So these are the ions protonating this. So this one uses its lone pairs to attract the proton. That is what we call protonation. And then it forms this intermediate compound with hydrogen. This has a positive charge because it has used its lone pairs. So it forms a positive charge there with OH. That is the first step, which is protonation. Now, in the second step, you have this compound, the same compound that we have there with hydrogen and OH. So this positive charge is neutralized by the bond. So this bond breaks to neutralize the positive charge. And in that case, when the bond breaks, then this one forms a carbocation. It forms a positive charge. So you'll have an alcohol, which is CH2Al. This is the alcohol. We have the same alcohol here. Then with its lone pairs attacking this carbon that contains the positive charge. And then it will form this compound here, Al, with say, this is OH. Then this is OH here, which is the same as this one. Then you have this oxygen with hydrogen, and then CH2R. Remember, this oxygen used its lone pairs, so it will form a positive charge. So that is the compound that is formed. So what happens next? So this positive charge, so we can bring that one there to just be precise and go slowly. So we have this H, then you have oxygen with hydrogen with a positive charge, CH2R. This compound is the same as this. I've just brought it here. So this means the hydrogen, what happens here, there is what we call the proton shift. What do we mean by the proton shift? This hydrogen that breaks away to neutralize the positive charge here doesn't disappear. Instead, it rearranges one of either this one or this. One of the oxygen atoms of the OH attracts that proton, and then it will form this compound. OH with O, this one comes here. So one of the hydrogen that breaks here now comes here. That's why we have this compound there. This is OCH2R. So that is how it goes. What happens next? Water is eliminated. So we are eliminating water. How is the water eliminated? Look at this structure that we have written. So this structure, the water, this is a positive charge. So this water breaks in that form. So this bond, the bond is made up of electrons, remember? So these are protons. So this bond breaks to neutralize that positive charge. Then the water is eliminated. So when the water is eliminated, what remains? Let us see. So we're having R. This is R. Then we have C with OH. Remember, the water has been eliminated. And then we have oxygen, CH2R. So remember, when the water is eliminated, this carbon also becomes positive. So what happens then for that positive charge? So there will be rearrangement of the bond as the hydrogen breaks away, and then it forms the final compound. Now, when this bond rearranges itself, so it will form a double bond. And therefore, you'll have R with C, double bond. You have oxygen, CH2R. That is our carboxylic acid that is formed. So this is how the reaction is taking place. So you can go through the steps slowly. If I hope you are putting it down and in your notes, because this will help you. And then see whether you can use. So use a specific alcohol. So here I was just using general form because I'm not specifying an alcohol, I'm not specifying a carboxylic acid. So use specific alcohol and specific carboxylic acid, and then try to come up with the final product. This is the ester that is formed. Remember, minus water, we said there is plus water, which is formed. The hydrogen has been eliminated, that has been eliminated or so. What does this mean? We started with the hydrogen, and we already have the hydrogen at the last. It is not consumed within the reaction. If a substance takes part, is not consumed within the reaction, it means it's not taking part, it's not part of the reaction. And in that sense, we call it a catalyst. That is, the hydrogen concentrated sulfuric acid is used as a catalyst. Take note of that. In this reaction, in the esterification, hydrogen, concentrated sulfuric acid is used as a catalyst. Let's proceed and look at other reaction. That was a reaction between carboxylic acids and the alcohols. So we'll go to another reaction where we are going to look at the reaction of alcohols and concentrated sulfuric acid. Concentrated sulfuric acid. So this reaction, the concentrated sulfuric acid reacts with alcohols under three conditions. Under three conditions. So that means this reaction is divided into three parts. So we are going to look at the first part, the second part, depending on the conditions for the concentrated sulfuric acid with the alcohols. The first part of the reaction is when the temperature, or when at 0 degrees Celsius, alcohols reacting with concentrated sulfuric acid at 0 degrees Celsius. What is the product? Let's assume of any type of the alcohol, and it is reacting with the concentrated sulfuric acid at 0 degrees Celsius. So this will form ethyl hydrogen sulfate. Ethyl hydrogen sulfate. This is, you can call it, no, alkyl hydrogen sulfate. Alkyl hydrogen sulfate. But even in presence of the water, they also hydrolyze into the alcohols again. So the reaction, we can also look at the reaction B. The reaction with concentrated sulfuric acid at 140 degrees Celsius. You remember we said at 0 degrees, it forms alkyl hydrogen sulfate. At 140, what is the product that will be formed? Let's look at the product that is formed. So we have an alcohol, which is CH2O, plus the concentrated sulfuric acid. This is the reagent that is reacting, but it is reacting at 140 degrees Celsius. 140 degrees Celsius. That is the condition for that reaction to occur. And what is the product here? CH2O, CH2R. When you look at that product, the reaction that is occurring plus water that is formed, this is an ether. This is an ether. The product is ether, which is different from ester. Look at the ester. The ester has 2 oxygen atoms. This is an ether. It has 1 oxygen atom. This is the functional group of the ethers. Let's check the mechanism for this reaction. Now, for the reaction, from the mechanism for this reaction, maybe you can just come back to this side. and look at the mechanism for that reaction, where the carboxylic acid, where the alcohol is combining with the concentrated sulfuric acid at 140. The mechanism, how does it go to come to an ether? So this is how it happens. So you have an alcohol with OH. So in most cases, the concentrated sulfuric acid ionizes to form the hydrogen ions and the hydrogen sulfate ions. So the hydrogen ions usually have to protonate the alcohol. So when you add the hydrogen ion, this one uses the lone pairs to attract the proton. And then it will form RCH2 with oxygen. The hydrogen has been added there. This hydrogen added here, so it forms the oxygen. Now, in this case, it forms the water with a positive charge. So this positive charge, this bond breaks to neutralize it. And then you'll have CH2, because the water has been eliminated, this one becomes a positive charge plus the water molecules which have been eliminated. So this one important other condition that probably I shouldn't forget to remind you is that the alcohol must be in excess. That is another condition that is very important here. The alcohol must be in excess. So the alcohol, this is the alcohol, and now with its lone pairs here, now we'll attack this carbocation. And then you'll come up with, eventually you'll come up with, this is RCH2 with oxygen, but there is a hydrogen here. This one becomes positive, and then you have CH2R. So what happens? This bond breaks still to neutralize the positive charge, so that is minus a proton, and therefore you'll end up with CH2 or CH2R plus the proton plus the water molecule. Remember, this proton came from the sulfuric acid. Now, if it came from the sulfuric acid, it means that the hydrogen sulfate ions will react with the proton, with the hydrogen ions to regenerate the sulfuric acid. Remember what I talked about in the previous reaction of the esterification. I said concentrated sulfuric acid is a catalyst. So similarly, in this reaction, it is a catalyst as well. So that is how the ether is formed. So use a specific alcohol. Here I use the general alcohol. So use a specific alcohol. You can write an alcohol and then use that specific. It can be ethanol, it can be propanol, it can be any other type of alcohol, and then suggest the product of that alcohol or of the reaction. So let us look at, again, another type of reaction, which is, I said, the third reaction under reaction with the concentrated sulfuric acid. You said 0 degrees Celsius, 140 degrees Celsius. So we also need to look at the reaction of the same concentrated sulfuric acid at 180, usually 170 degrees Celsius to 180 degrees Celsius. So this gives another reaction. If you remember very well, when you are looking at the reactions of the alkenes, how the alkenes are formed, one of the important reactions that you looked at was dehydration reaction. Do you remember that reaction? I think so, you still remember. because it is a very important reaction. So in this case, if you have the alcohol and is reacting with the concentrated sulfuric acid at 170 degrees to 180 degrees Celsius, the product will be an alkene. So you'll have an alkene formed as a product, and then plus the water. This reaction is dehydration reaction. Dehydration reaction. Or elimination reaction. What is the mechanism? The mechanism is still the same. So you'll have R with CH2, oxygen, plus the proton. The proton is coming from concentrated sulfuric acid. So this one will attack the proton, as we said before. So it will form R, CH2 with OH2. This is a positive. So that is the water. So there is elimination of the water, and then you'll have R, CH2, CH2, then you have CH, you have RCH, so this one becomes positive when the water is eliminated. So you'll have, now you have CH2, water is eliminated. So we said in this reaction, we need, when the water is eliminated, this is what is formed in this form. So we have said it forms an alkene. So we need another reaction. An alkene will be formed. This will be the final product, and then the water that will be formed finally. So the alkene that is formed is, that's why we said it is elimination, because water is eliminated, or it is dehydration. Dehydration is the removal of the water molecules. So this is similar, so probably, now I have to change this one a bit. So this will be CH2OH. Let's use that one. So this is how it is. Now, can we look at the homework? Just copy this work as we go through. Copy and complete the reactions below, and suggest the mechanism for each. A, we have CH2, let be specific, CH3, OH, 5B, CH3, CH2, OH plus CH3. This is a carboxylic acid in the presence of concentrated sulfuric acid and heat. And C, CH2OH plus CH3, COOH, the same reaction. And D, you will give the alcohol, which is ethanol, plus concentrated sulfuric acid in presence at 140 degrees. So that is the homework. Try to react to do the homework, finish, and then suggest the mechanism for those reactions. Thank you so much for watching and listening. I hope to see you next time. Bye.